Fantastic, right.
Okay, so I'm David Waltham. I'm Professor of Geophysics at Holloway, part of the University of London, though I do live in Marlborough, so I'm a local person. I work in the Department of Earth Sciences. I run something called the Centre for Energy and Resources in that department. And I thought I'd actually just start off by saying a few more words about my background, so you can actually judge whether to believe anything that I say tonight. So I'll give you some idea of that. So this actually is my background. I've been working for over 40 years in oil and gas exploration, which might surprise you. Right, this is what I started off doing. This ship was collecting data for oil and gas exploration, and a large part of my career has been spent in working out ways to use that data to get better and better pictures of what's under the sea floor, and thereby helping oil and gas exploration. But, and it's a big but, I've rather changed my direction in the last 10 years or so. And these some of the reasons why. So on the left there is a book that I wrote just over 10 years ago, and it was a book about Earth's climate on a really, really long timescale, looking at how the Earth's climate's changed over billions of years. And as part of that book, I wrote literally 3 pages on modern climate change. But in order to write those 3 pages, I did a little bit of background reading and a bit of research into it. And I was actually rather shocked to discover that a lot of the climate skeptics' arguments, they nearly all seem to me to be based on half-truths, dangerous half-truths. It wasn't that they were wrong, it was that they were only telling half the story and therefore able to say something very misleading. So that sort of got me thinking about, well, maybe this is something that I need to be taking much more seriously. Then in 2016, this report came out from the Intergovernmental Panel on Climate Change, which is a UN scientific organisation that produces periodic reports about climate. And this particular report showed that we really needed to try and stop climate change at 1.5 degrees of warming. Until that time, pretty much all of us had thought 2 degrees was fine. 2 degrees wasn't the problem. This report came out and said, no, 1.5 is really what we should be aiming for. And that was particularly shocking because at that time, temperatures had already risen by about 1 degree. So in effect, it had halved the room for manoeuvre. You know, we only had half a degree to go rather than a whole degree to go still. So that really focused the mind, not just me, but many other people. Greta Thunberg, for example, was very much influenced by this report. And then the last report I've got up there, from just three years ago or so, it's from the International Energy Agency. Now, it's an interesting organisation. The International Energy Agency was set up just after the Israeli-Arab War of 1973. And some of you might remember at that time there was an embargo on oil. Most of the world's oil at that time was coming from Arabic nations, and they actually stopped letting the West have it. And as a result of that, in the aftermath, this organisation was set up by Western governments to try and secure future supplies of oil and gas. So my point is that the IEA has got oil and gas in its bones, it's in its DNA, it's part of why it was set up in the first place. But despite that, in this report, they came out and said 3 years ago that we didn't need to look for any more oil and gas. We can't even use all the oil and gas we've got. So we need to stop looking for more. There's no point in looking for more. Can I take questions at the end? Is that all right? Yeah? I'll talk about questions in a minute, but yeah. So those are the sort of parts of my journey. So I'm very happy to take questions on this later. And as a result of that, I've kind of changed the things that I teach and the things that I do research on. So I'm still doing quite a lot on ancient climate change, so this pointer's working. Yeah. This is actually the Earth's temperature history over the last 400 million years that you're seeing in there. So that's certainly one of the things I still work on. Recently I've started working on this. It's absolutely fascinating. Natural hydrogen. I didn't even know there was such a thing until a couple of years ago. There's increasing evidence that there's large deposits of completely natural hydrogen under the ground, which we might be able to exploit as a very cheap, very clean form of energy. So that's fascinating. It may turn out to actually be exaggerated, and there isn't that much of it, we don't know yet. I also work a lot on energy storage, underground energy storage. So renewable energy, as I'm sure you all know, is very intermittent. Sometimes we've got too much, sometimes we haven't got enough of it. The obvious thing to do is to store it. But storing it in batteries for long periods of time is actually just far too expensive. We can't do that. We need cheaper ways to store energy. And storing it underground is probably amongst the best options. So you can do things like storing hydrogen underground or storing compressed air underground and so on. So that's another area I work on. And then finally, and this is one that some of you may want to disagree with me about, carbon capture and storage. This is actually a rig in the North Sea, a place called Sleipner, which has been burying 1 million tonnes of carbon dioxide under the sea floor every year for the last 30 years. The idea that carbon capture and storage doesn't work just isn't true. This has been doing it for 30 years. So that is something else I work on, but I do appreciate that that's controversial, to say the least. These are the areas I'm working in. So that gives you some idea of my background. What I wanted to do next before I actually get into the talk proper, I just wanted to do a little exercise with you all. Based on these climate stripes. I'm guessing most of you have seen the climate stripes before. They're not that unfamiliar to you? No? Okay. Right, this was invented at the University of Reading. And it's a way of illustrating climate change over time. So what we've got on the left-hand side there is about 1870, going up to the present day, 2023. And each of the stripes is a different year. And if it's dark blue, it was cold that year. And if it's dark red, it was very hot that year. So what we're seeing is, from the late 19th century into the 20th century, lots of blue colours. We get to the 21st century, it starts to go red, and it goes very, very red. It's just a way of illustrating that the temperature changes are, there's a very, very strong acceleration in warming as we get into the 21st century. It shows that quite nicely. This website, if you've got a phone on you can type that in and have a look at it. I'm going to put it up on this screen in a minute for those who haven't got smartphones on. It's a website again from the University of Reading. But what it allows us to do is to look at the stripes for different locations. One of the problems with this chart is it's based on an average of the world's temperatures. So it's a global mean temperature. And that's actually a very difficult thing to calculate, especially through time. If we go back to the 1870s, there were large parts of the world that didn't have any thermometers so that anybody regularly measured the temperature even. So we've got that change through time as the distribution of measurements. And you need to work out ways to average it accurately. It's quite hard to do that. You need to, in some places, you've got very few measurements, so you need to put a big weighting on that measurement because it's effectively covering a large part of the Earth. This has been criticised by skeptics. They basically say you can't easily work out a global average, so why should we trust this data? So that's actually what I wanted to look at first. If we go to that site, just put the microphone there a second. Okay, so this is what comes up. It starts off with the globe, and that's again just those climate stripes. But what you can do with this now is we can actually look at the stripes for the particular parts of the world. So I'm going to start by looking at Oxford, which is quite near here. Right. Struggling a bit with this touchpad. Right, that's Oxford. The reason I picked Oxford, apart from the fact it's very near here, is that that's a continuous record in one place using more or less the same equipment, stretching back to the early 19th century. So there's no averaging problem here. And you can see exactly the same pattern. We've got blues all the way through until we get to the 21st century and it starts to get much, much warmer. So the game I want to play, as you can do it on your phones or you can shout out, can we find something in the world that doesn't have that pattern? Right, spoiler, there is somewhere. But not very many places. Right? Almost everywhere we look at shows the same pattern. Antarctica, let's see, I'm not sure it goes down to Antarctica, does it look?
Pakistan, somewhere in the, somewhere in Pakistan.
I don't think we're going to get Antarctica.
Somewhere in Pakistan, but I can't remember where it is.
Right, we'll have to look at Pakistan. So we go to Asia.
It's in the mountains in Pakistan, I think. It's the Himalayas or somewhere. Pakistan Himalayas?
Well, we need to pick a city. I'm just going to go to Peshawar. Right? Now, it's a bit noisier, but it's still the same basic pattern. Mostly blues, going red up.
Costa Rica.
Costa Rica, okay. Central America, I guess, is it?
Yeah, it is. No, it's Caribbean.
Okay. I think it's worth taking the temperatures from because there's urban spread with that as well.
Sorry?
There's urban spread wrong with that as well, the earth population can up. So if you've got a thermometer in the 1930s and it's still in the same place, whereas it just got all the town.
We also take into consideration so many other factors which cause certain heat build-up, you know.
Not that much.
Okay, so what about the stations at RF Coningsby and Heathrow? Yeah. Well, that puts data into here. They do a lot of flying.
This is Costa Rica.
I know, but I'm just saying.
Yeah.
I'm supporting that chap's point that you're completely ignoring population growth, urban density, and the use of infrastructure in that data.
No.
Really?
No.
San Jose is a city,
Yeah.
so it has grown. You're saying no, why are you saying no?
I'm saying the effect is small. I'm not saying it's not there. It's a very small effect. This is a much bigger change in temperature than you can explain what heat
Oh,
was.
yes, of course, but we're coming out of the little ice age. We're in an interglacial period.
No, that's correct.
So now you're saying that there is warming, but it's natural.
Yes, it's entirely.
Making my little child can we get back to that later? Point is, can anyone find me a place where this isn't happening?
Try
I
Svalbard.
can't find the one that I gave you, which is actually happening. Antarctica is getting colder year on year because of CO2.
So let's try Svalbard instead. That's not
Well,
Antarctica.
you're with the opposite pole.
Yeah, the Arctic.
With the Svalbard count as Europe?
Sorry? Yeah, I think it's.
If you look at the map, there's no dots in Antarctica. Look at the world map.
Move your finger to the left.
Well, to Hungary, sorry. Norway, right. Norway. Yeah, that's Svalbard, isn't it? There we go. So there's Svalbard. Slightly more interesting pattern. Certainly no heat line that affects this whole
Can you try somewhere near the equator, so Nairobi and Egypt, for example?
Yeah.
Okay.
Sorry, I'm struggling with this touchpad. There's Niger. Is that close enough for you?
No. Go to K, Kenya.
Hawaii.
Try and get this one.
There we are. Put your finger on the left-hand side of the pad.
There we go. Got Kenya.
Yeah. Hawaii.
Nairobi.
Somewhere in the middle of the ocean.
Same place.
What are the temperature variations? What's the temperature of that end of the scale?
Right, the temperature change is a couple of degrees, typically, from the lowest to the highest, so they're around about 2 degrees.
2 degrees.
Yeah. So, let me give you the answer, so we can move on. The answer is Canada, towards the centre. This is like Calgary. Yeah, even there, I think you could claim that there's much more red on the right than there is on the left. But it is a more complex pattern.
Any idea why?
No, actually, I have no idea why. Okay, let's get back to the talk. And then we'll go with the questions later. I'm looking forward to them, actually. Right, so back to the talks can be a full Net Zero. So the reason I wanted to talk about this is because it is something that seems to be happening at the moment. There's a lot of discussion about this. Right, so this is an article in the Telegraph by Craig McKinley. Craig McKinley was part of the Conservative group of MPs called the Net Zero Scrutiny Group, and he's certainly been asking questions. This is an interesting article, it's worth reading, but again I would say that whilst a lot of what's said in it is actually completely true, it still contains misleading half-truths, in my opinion. This has also been recently said, so Kenny Badlock, now the leader of the Conservatives, has described herself as a net zero sceptic, but not a climate change sceptic. Now to me that's an incoherent viewpoint. Why? Oh, I'm going to tell you. Because the science is quite clear that the only way to stop climate change is to completely stop emissions. I'll talk later about how we might tackle climate change. But again, I'm not going to talk specifically about that today. So what am I going to talk about? I'm going to say a few words, at least, about how much it will cost us to tackle climate change. Right, there are some estimates, give you some idea what the sorts of sums are. But then obviously, I think, I'm going to talk about how much it will cost if we don't tackle climate change. And obviously, I think we need to look at both sides of that equation before we can decide whether we can afford or not afford to carry on with it. So look at those two questions. And I'm going to finish with this question, and why should we pay? Now what I mean by we here is UK citizens, either paying through our taxes or paying through increased costs of the things that we buy. Now, should we do that, or actually should someone else be paying rather than us? So those are the three things I am going to talk about. So, as I said, costs. There are quite a few estimates around. One thing I would emphasise is you really need to take these costs with a very, very big pinch of salt. The changes we're talking about here are enormous, and and it's never been done before. So they are all, in a sense, guesses. They're estimates based on some kind of reasoning, but until we do it, we don't really know for sure. But nevertheless, the estimates that are out there are coming to similar conclusions. This is a very recent one. You see the date there, October 29th this year, so that's just a few weeks ago this particular report came out. And it was suggesting that the sorts of investments that are needed in order for us to get to net zero, something like $3.5 trillion a year. This is worldwide, not just in the UK, but a worldwide figure. Now that's at the upper end of figures I've seen in various reports. Other reports are in sort of $1 to $2 trillion per year level. But quite honestly, at this stage, all we can really say is it's going to cost trillions of dollars. So if we have to do it, we could do it. But how much will it cost us if we don't do it? Well, there are estimates of that as well. This is a slightly older estimate. You can see here it's from 2022, a different report. $178 trillion by 2070. So this isn't a per year sum, this is a total up to 2070. But it's easy enough to calculate what that is in terms of per year on average. And you can see it's a very similar number to that last one I just showed you. 2.7 trillion a year. Some of the estimates are rather bigger than that. This is a lot bigger. 38 trillion a year. This is a much more recent report, this one. You see April this year, this figure that has come out. That's much bigger than anything I've seen from other places. So these are the costs of doing nothing. Right? These are the costs due to loss and damage. It's due to loss of life, loss of property, failing crops, all those sorts of things. Those sorts of costs. So the conclusion that you come to from that, and I think it's the best you can do, is to say that as far as we can guess, it's going to cost trillions of dollars a year to do nothing and just pay for the damage, and it's going to cost trillions of dollars a year to actually do something about it, to actually build the technologies and the infrastructure that we need to tackle climate change. So at that point it sounds like it's 50-50. It's about the same amount of money either way. That's something I would strongly disagree with. And it's for this reason, it's two completely different sorts of costs. If we use that money to pay to build a new and better world, a cleaner world, a safer world, it's like paying a mortgage. You're basically paying money to have somewhere nice to live. On the other hand, if you're just paying out the same amount of money because of all the damage, because things have got lost, things have got broken, lives have been lost, etc., you're not getting anything. It's like setting fire to money. It's the same amount of money, but if I'm spending that much money, I'd rather spend it on a nice new house than just keep taking the banknotes out of the cash machine and setting fire to it. So I think they're actually very different costs, in my view. So although they do come out at the same level, I would argue we're much better off paying to try and prevent climate change. So that's my answer to the first two questions already. How much will tackling climate change cost? It will cost trillions a year, but it's an investment. It's an investment in the future. And actually many economists think that in the longer term it will make us money. And that's because these kinds of things that we need to do, electrification, moving away from old ways of doing things to newer ways of doing things, they are actually fundamentally more economically efficient. And therefore in the longer term they will actually save us money. But that's another argument entirely, and you may or may not go with that. How much of it will not tackle climate change cost? Yeah, trillions a year, but it's a pure cost. It's not. There's no benefit for that money that you're spending. It's purely going to compensate you for the losses that you've had. So let me move on then to that third question. Should we pay? As I say, you and me, us in this room. Now my immediate sort of emotional reaction to that question, it sounds to me like a teenager who's using to clean their own room. Of course we should pay, so should everybody else. Everybody should make their contribution. That's my sort of emotional reaction to this. But let's perhaps look at it slightly more rationally. But the reason why people ask these questions, well, I'm going to go through several reasons why people ask this question, and give my response to it. One point that's often made is we've already done a lot. This is a UK government web page announcing that the UK is the first major economy to halve emissions, and that's technically correct. We have, and no other large economy has achieved that yet. So yeah, we've done a lot already, and we've done enough. Somebody else has done. That would be part of the argument. And you can see that on this plot here. This plot is actually showing the UK's share of emissions over time. What's happened to those emissions over time? So if you go back to 1800, the Industrial Revolution started here. We should be very proud of that fact. But as a result of the fact it started here, initially all the fossil fuel emissions were here. So we're at 100%. But then as other economies started to industrialise, other countries started to produce greenhouse gas emissions, our share dropped. And you can see we're now down there at about 1%. So we're now only emitting about 1% of the emissions. So the argument might be, we're a small country, our contribution to total emissions is very, very small, we can't really make a difference. Again, an emotional response, and then I'll give you perhaps a slightly more rational one. To me that sounds like an argument along the lines of, it's all right to drop litter as long as you drop less than you used to. I took these pictures outside my house this morning, this afternoon in fact. If you're wondering, I did pick them up afterwards and throw them in the bin. Right, so that's my emotional response to, okay, maybe it's much less than we used to emit, but we're still emitting. And we still have a responsibility to stop doing that. But another way to look at it, start with this plot. So this again is the kind of argument that you'll hear. This is the total annual emissions from the UK through time, and from China through time. So China overtook us in around about 1970s, late 1960s, I think it is, in here, and it's been going up very strongly ever since. By the way, there are strong hints at the moment that China's emissions are about to peak and start dropping. I hope that's true. That's not confirmed yet, but I hope that is true. So looking at that, again, it looks like, no, China's got to do all the work, not us. So the argument here effectively is to say small countries don't matter. The emissions from small countries like the UK are such a small part of the total, it really doesn't matter what we do. And my argument against that would be that, okay, small countries don't matter, why don't we just break China up into its provinces? So here's China, it's got 23, I think it is, provinces, they're all about the same size as the UK in terms of population. If China was to break up into all those separate little provinces, we'd have lots of little countries that don't matter, according to that argument. Now, of course, this is nonsense. It's meant to be a silly argument. The point I'm trying to emphasise here is it's not the total emissions from the country that matters, because that's clearly going to be biased towards big countries rather than small countries. What actually matters is the emissions per person. That's the real comparison to make. To look at emissions per person, it's a very different picture. Perhaps we should ignore the United States for now. I'm comparing the United Kingdom to China here. Now you can see our emissions, they've been dropping since around about the year 2000, they are falling nicely. China's emissions have been going up steadily, and these are emissions per person, we pretty much met in the middle. We're both well above the world average.
Excuse me, just on that. It says on there, production-based emissions, emissions minus the emissions generated in the production of goods and services. China produce everything going on around the world, that's bound to knock that figure down.
Not sure I follow the argument.
It says on there,
Yeah.
they are calculated as domestic
Yeah.
emissions minus the emissions generated in the production of goods and services.
Yes.
They've not taken.
These are consumption-based emissions. These are not territorial emissions.
I know, but
Yeah.
you see what I'm saying?
We're gonna do
They're not
questions at the
including
end.
all the production, all the manufacturing that goes.
Yeah, exactly. Effectively, we've exported our emissions to China.
Can we do questions at
Hey,
the end?
excuse me, I'm really enjoying this. You might not be, you might not continue to argue, but I've come here to understand. So can you do the questions at the end, please, so I can understand it? He's asked you twice.
Of course I will.
Do the questions at the end.
He hasn't asked me to.
Okay. I mean, it is a fair question. Let's come back to it.
Okay.
Yeah. Right. So my point here then is that the United Kingdom and China are pretty much the same on this particular basis. China, as I said, is likely peaking about now. So China's going to start going down, we're going down. What I hope is that we'll go down together at this point. And hopefully then take the rest of the world with us. So, yes, another argument. Hopefully you recognise this from the Jungle Book. It's the scene where the elephant troop is asked for a volunteer, and all the elephants except one step back. Now, what I'm trying to illustrate here is the idea that one of the issues, and I think this is a genuine issue, is, what if we're the only ones doing it? What if everybody else just lets us do what we're going to do, but they don't follow suit? Under those conditions, we're in danger of actually getting hit twice. We have to pay for the transition to net zero, and we're still getting hit by climate change, so we're paying those costs too. I think that's a serious issue. I think that is something that needs to be worried about. It's actually an example of a prisoner's dilemma type of problems. What's going on here is that if each country purely thinks about its own self-interest, if it actually says, I'm going to do what's best for my country, then every country will decide to do nothing. And that's really bad for all of us. It's the wrong outcome. We want to avoid that. Now, in game theory, and this is all very theoretical, but in game theory, I'm not a diplomat, in game theory, this is the usual solution to that problem. When you've got those kinds of problems, this is what game theory suggests you should do. You should follow a strategy of what's called tit for tat. Now, what tit for tat means is that you start off by being nice, and you hope that the other people are going to reciprocate. And if they do, you carry on being nice. If they're not nice, you stop being nice. So that's the tit for tat strategy. This is possibly the only way of moving this thing forward, so that we avoid the every country for itself ending in disaster problem. Now, in my view, and you may well disagree, I think that's what our PM has just done. So, literally 2 days ago, in COP29, this was this statement, we're building our reputation, the UK's 2035 target is an 81% reduction. That's a really very ambitious target. Well, I think it's out there in order to try and encourage some reciprocation. And I think that is actually the only way forward. So I'm actually very proud that our country is doing that. And I would strongly support it. It may not work, that's entirely possible. So, some conclusions. Looks to me, from what I've seen, that doing nothing costs about the same as tackling the problem. The costs are similar. Again, that's a very, very rough and ready statement. We don't know the real costs either way. So, as best as we can guess it, the costs are about the same. But paying for damage and loss is a pure cost. You're not getting anything from that. Whereas paying to avoid damage is an investment in a better future. So that's why I think, given that the costs are about the same, that's the sensible choice to make. This very much is a point of opinion. In my opinion, the UK has a responsibility to lead. Also, I don't really have time to talk about this very much, but it's quite likely, many economists' view, that we'll gain economically for doing so. So actually, that might be the net benefit to us anyway. Next step for sure. So this meeting's been set up by people sitting at the front here. And they're quite keen that we actually do something concrete at the end of these meetings. So I've got a particular thing we're going to come back to later that you might want to think about getting involved in. And that's the CAN bill. So CAN stands for Climate and Nature, the Climate and Nature Bill. This bill has not been put forward by any particular party. It's a private member's bill. It's that MP won the ballot and is putting the bill forwards. What the bill does is some of its outcomes creates a joined up plan. Essentially it's about the climate crisis and the nature crisis, biodiversity as well as climate. They are deeply entwined. It's probably the two together. It commits us to trying to cut our emissions in line with a 1.5 degree centigrade target. This is about nature. I'm going to stick to climate. It ends fossil fuel production and imports as rapidly as possible. And as I said earlier, even the International Energy Agency thinks that's what we should be doing. Critically, this is something I've not had the time to talk about at all. Sure as nobody's left behind. One of the big problems with all of this is that the costs, whatever's causing those costs, whether it's the cost of doing something or the cost of doing nothing, either way, those costs tend to fall on those least able to pay. If we're going to make progress, we need to make sure that doesn't happen. So it's about fairness. It's about ensuring that the burdens are shared equally, preferably not by people who can't bear them. And finally, it's going to involve the public through assemblies, people's assemblies. So this is the bill, and there's a critical date coming up, 24th of January. This is when it's having its first reading in the House of Commons. And if enough MPs turn up and vote on it, then it will go to the next stage. It will go to the committee stage and get scrutinised in detail. So this is quite critical. If this bill is to go forwards, what we need is for as many MPs as possible to actually turn up, because if not enough of them turn up, it doesn't matter what they vote, it won't go through. Forget what the critical number is, it's 100 MPs or something like that. We've got to turn up, and then it's got to get voted for. So we're going to come back to this later and what you can, if you wish, do to help make that happen. But we're going to come back to that. Other than that, I've finished the formal talk and I am now going to take questions, and I think I'm going to be given an interesting